Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is ITX 10 Cipher Examples using the GSKIT. Feel free to follow me on popular social media channels at Paul Brett IBM. With a default ITX 10.1 installation, this example can be found in the directory shown on screen. The map source file is called cipher.mms. Within there are 7 examples, 4 for enciphering and 3 for deciphering. Here we are connected to my remote virtual Windows machine, and I'm going to open the folder where the Cipher example can be found. Here you can see the cipher.mms that I mentioned in the previous slide. Now I'm going to fire up the Design Studio and walk you through the different elements of this map source file. Opening the map source file, you can see the 7 examples I spoke of before, and we're going to start by looking at encipher. This map has 2 cards, one input, one output. On the input side we're reading a file called test.txt, and if we have a quick look at the content of that file, it just says hello world, encrypted password in plain text, and it ends with a carried return line feed. On the output side we have one output card, and we have a get from the Cipher adapter wrapped in a valid function which will trigger a fail function if there's any problem. The arguments to the Cipher function are to pass in the mkf file, the action of encipher, and turn on the trace. So let's build and run these maps. Starting with encipher, let's go for build all, and then encipher we're going to run. Back in our file list, I'm going to open a command prompt and do a bit of cleanup, so we can see the actual files that were created by the run instead of the compile step. There's all our compiled maps, and we have the adapter trace file m4cipher.mtr, and we also have encipher output.txt. Quick look at this file, and it's all completely indecipherable as it is now. Moving on to the decipher map, fairly similar to encipher. We have one input card, one output card. The input card is reading the file that we just created, encipher output. The output card has a similar rule to the encipher map, and in this case we're still reading the same mkf file. We've got the action of decipher and still with the adapter trace. So let's run this map. Map completed successfully. Back in our file list we now have decipher output, and if we have a look at the content of that, it says hello world, encrypted password in plain text, and you will note that the data still has a carried return line feed at the end. It has been recreated exactly as it was in test.txt. So that's the 2 simplest examples of using the encipher and decipher commands with the Cipher adapter in a map rule. The other examples are showing you how to use it in cards, and there's also an additional example of how to encipher a binary file. We'll go through the card options next. For example, we can encipher with an input card. We select the cipher as the source for the card, and the adapter commands go in on the command line there, including the -file option to read a particular file. And it's expecting that file to be in the same place, or at least referenced as a relative location from the map directory. On the output side we're just writing out a file, encipher in file output. So the enciphering is being done in the input card in this case, and then within the map you've got the enciphered data which is being put by the output card. When you want to use an output card instead, we are reading a file called test.txt, and this is very much like the encipher with a rule, but instead of using a rule we're using the actual card. And here we're using the Cipher adapter. We have -file to say what the output file needs to be, action of encipher, and the MKF file is referenced, and again the adapter trace. Similarly, on the decipher side, you can decipher using an input card. You reference the file in the adapter command line. This means that the data going through the map is already deciphered. It's been deciphered by the input card. In the decipher out file example, you've got the enciphered information coming in via the file adapter. The encrypted information is going through the map, and you're only deciphering it when you get to the output card, and you're using the cipher adapter, the dash file, and the dash action decipher command there. Let's have a quick look at the encipher_bin map. This is fairly similar to the encipher map, the only difference being that it has a dash bin option in the adapter command line. And when we run that map, we can see that the output from that has encoded the data in a binary format rather than plain text. So there we have it, a quick run through of the Cipher adapter using ITX 10.1. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please hit that like button. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Thank you.